Here's my first home automation project. To start, uh, we would need to choose a microcontroller between Arduino, Raspberry Pi, and Node MCU. I chose a Node MCU, and I'll tell you why. Arduino is really cheap and great for school level programming. When all your inputs or outputs are in the form of a digital or analog voltages, right? It allows you to really very easily program a plug-in microcontroller that you see here that's plugged in onto this board for use in disconnected devices like dishwashers, microwave ovens, etc. But any advanced I/O requirements like wireless capability or display capability, etc., that would require expensive add-on boards that negates its advantages of low cost and simplicity. So this is something that I did not use for my IoT project. The second option ahead of me was Raspberry Pi, which is a small computer on chip. It runs off a very powerful Qualcomm processor, very similar to what you have in basic Android mobiles. It has all the bells and whistles, Wi-Fi, HDMI output. It has persistent storage on SD card, which means it can run really complex operating systems like Linux. So it resembles more closely to a small computer. It's actually like very much similar to a Amazon Fire Stick, right, than a plain vanilla microcontroller. So you can use its strong HD video capabilities to run media centers like advertisement, billboards, self-service kiosks, etc. But just for home automation, I believe this was an overkill. So I didn't take this up either. The last option, which I eventually ended up using, was the Node MCU. Right? Node MCU is a board which has an ESP microcontroller, a USB to serial converter, and a UART bridge that allows you to directly program it using your computer without any additional devices. No other devices are required. It has a micro USB port which connects directly to the computer. The reason I picked this up is because really 3 or 4 major things. One is it's a very small board. It mounts right on top of a regular sized breadboard. It's Wi-Fi enabled, and it runs off any mobile USB power adapter, right? So it sips minimal power and can be programmed using Arduino IDE, which is the IDE that is most commonly used for microcontroller programming. So let's look at more closely at this board, especially its components. So this is the ESP8266. That's the microcontroller that is embedded onto this board. The board is a programming board, so it has something else apart from the microcontroller. It has a voltage regulator to run the microcontroller. It has a UART bridge for the programming interface with USB. It has 2 LEDs that you see here highlighted in blue and red. Both of them are blue LEDs, by the way. So they are connected to the D4 and D0 data pins. So the graphic that you see on top indicates how they are connected internally to those 2 pins. So if you are using those 2 pins for your IoT, then you can even get a local reference to the pin value using those LEDs, right, on board LEDs. So now we are going to build the home automation system using the Node MCU. Really, we don't need all this that you see on this on the screen right now. We really need only two other devices apart from the Node MCU. Right? One is this relay that you see here, and the other is this 5-volt power supply. Everything else that you see here is only required if you want to keep your Node MCU for yourself or your other experiments, and you want to make a really minimal IoT switch, which is just using the microcontroller that was on top of the Node MCU. So you can get that microcontroller separately on your you can get those off the market, right? So the relay module, of course, you can decide how many channels you want to use. I used a 2-channel just for simplicity. You can use 4 channels, 6 channels, even 8 channels could be supported by this microcontroller. So you see these are the 3 that you will actually need, and the rest of it that you see here, those are something you will need if you are planning to keep your Node MCU and not planning to put that in the IoT bridge. So once you have the Node MCU, the program is really simple, right? You just connect the Node MCU to the computer, install Arduino IDE, and set it up for your model of the Node MCU. I mean, there's a lot of internet literature around how to set up the IDE on your computer, so I would not go into the details of it. The code for automation per se is just 1 page, as you see here. That's about it, right? Every background work is done by the Blink libraries that you see here, referenced here. The Blink libraries do all the background work. The good old folks at Blink have developed these libraries for us to use. So yeah, just use the simple sketch. Before using the sketch, of course, you need to replace your details here, your SSID and password, and the token that you see here, you'd replace this with the token that you get from the Blink app that you install on your mobile phone. So the hardware connections for once you have programmed it is this, right? You connect the relay module to your Node MCU, and you drive the relay module using a separate 5-volt supply. You could of course splice your micro USB cable to get that 5 volt for the relay module, but don't attempt to draw the 5 volt directly from the VIN pin of the Node MCU. Otherwise you are going to cause the overcurrent protection to trip on the Node MCU, and it could cause damage to the board. So that's about it. I mean, just go to the Blink help pages on your mobile and see what else you can do with it. You could have dimmers and like timed turn on and turn off and things like that. All those are very easily doable right on the Blink app. Those are just configurable, right? You don't even have to code anything more than what you just saw. And if you're technically inclined, then you can proceed forward with this video. But really, this is all you need to build the IoT switch. But if you want to build the switch for commercial purposes and really don't want this entire Node MCU to go into the switch, then let's carry on. So like I said, for deployment on multiple systems, a Node MCU is an overkill, right? It has so many other things for programming which you don't want on the production system. So it's like yeah, cutting an apple with a chainsaw, right? Like you see here. So this is all you need really, not the Node MCU. You just need the chip that was on the Node MCU, which is the ESP12 chip. It's a chip, right, the size of your thumbnail, and this is where it was placed on the ESP, just to recall. Right, it's soldered onto the Node MCU, so we cannot take out that chip. So what we are going to do is we will disable the onboard ESP using a jumper and use an external ESP connected to the same pins, and we'll use an external ESP and program that using this Node MCU, right? So just to explain that better, look at what is there in Node MCU. So these are the modules, right? The module on the left top is the only one which we need, apart from the one on the left bottom, right, which is the power supply. We need only those 2 modules. Everything else is just dead weight. So we use the module and the power supply, and there is this nice little board that is available, which you can use to mount both of them. I didn't use it because I couldn't source it. It came from China, but it came in too late, so I had already built this on my own circuit board. So here's how you would connect the external ESP for initial programming while disabling the internal one. So this connector that you see here, the black connector between the enable and ground pins, this is what is ensuring that the onboard ESP is disabled. once the onboard one is disabled, you can program an external ESP by connecting that external ESP to the same pins as the onboard ESP would have been connected. So this is how the programming setup looked like. Of course, I had to do a couple of solderings on the ESP because the ESP12, the smaller module, doesn't have pins. So you can either solder pins, which are very difficult to get because they are too close to each other. The normal pins that you get, the pin strips you get, are not of the same size. So I just directly soldered them. So once you've programmed it here using the same program that we saw earlier on this video, you just put this ESP into the switch. So let's see how we will put that there. So this is the final connection of the ESP. The ESP, the relay module, the voltage regulator, and the power supply, of course. It starts from the right and goes towards the left. So the power supply, 5-volt power supply. We needed a 3.3 volt rail for running the IoT module, ESP module. So I'm using an AMS 1117. That regulator is not visible here on this video because it's at the back side of this this chip, this board where I've soldered the capacitor. That's the ripple reduction capacitor on top. It's optional, but I used it anyway just to make sure that there are no ripples and no unexpected reboots of the ESP. So the 3.3 volt rail is the I think the brown rail here. The brown rail here is 3.3 and the red one is 5 volt. So both the voltages are going into the relay module, and the 3.3 volt is also bypassing itself via the relay module into the ESP. So this is how it looks like. This is the final setup. I needed a box for it, so I just used a old outdated router, this one that you see here. The router motherboard that you see here, that went into the recycle bin, and the ESP I pasted it right on top of right behind the LED windows on the router case, so that when the blue LED lights up, it shows up on the LED windows. So that's the ESP, and that's the rest of the stuff in the main router box. So this is how the final installation looked like. Of course, without the ESP plugs in here with the case cover. It plugs in here right at the bottom, that 4-pin connector. So this is how it looked like after the ESP has been plugged in and it is functional just before it is closed. And this is how it looks like on the wall. So, and this is how it looks like on the phone. Right, the controls on the phone, very simple controls, just 2 controls for the two channel relay. If you want 4 channel, you can have 4 controls in there. So that's about it, my dear friends. Enjoy your day, and let me know in comments if you have any questions, if you wish to know more about the circuit, if you're facing any challenges when you are setting this up. Thank you and enjoy your day. Bye.